works out perfect every time. What if you got that scenario there? That's a possible answer. What is our, which one is the a squared? The y, the 36, right? And then, so a is what? 6. So a squared is 36. And then a is 6. Well, what's b squared? Well, it would be b squared is 12. B would be square root of 12, or what is it, 2 square root of 3? All right, that can happen. How would you graph it? You just have to estimate. You would go from your center up and down 6, and then you would go left and right, square root of 12. Okay, that can happen. Just make sure you don't say, it doesn't always have to be a perfect square. Also, what if you end up, like when you do the completing the square, what number was that? 56. Okay, so I'm going to go about halfway down. So let's say, read that. Where it says 9.
9x plus 4 squared over 36.
Oh, no, not that yet.
Oh.
Equal, plus.
Oh, plus 4 y minus 3 squared equals 36.
All right, so this is a typical step. We get to this point. So the equal 36 on that right-hand side. We're not done because it has to equal what? 1. So what do we do? Divide by 36. Now, this, for what we have done, has worked out nice. And for the most part, it will, because we're making the problems that work out nice. It doesn't always have to. It worked out nice because what's 9 divided 39 into 36 is what? 4. So it becomes over 4. And then this becomes y minus 3 squared over 9 equals 1. We don't want a coefficient in front of this right here. So it worked out nice. We got our a squared, we got our b squared. All right, what if instead of a 36 over there, let's just make it 48. So you did everything right, you got a 48. What do you got to do? Still got to do what?
Divide by 48.
Still got to divide by 48. So we're going to divide by 48. All right, now I'll address this here in a second. You're like, hey, that doesn't work, does it? But this one does. That'd be what, 12 over 12 equals 1. Can't leave that. I got to make this over a constant. You can do it. What would it be? What would go in the denominator? If I get rid of that, I got to get rid of that 9. Worked out real nice over there because 4 goes into 48. It basically simplifies to 1 over 12. What we do on that left-hand side? Okay. Justin, you got an idea there? No, not really. Because we need to, it's got to equal x plus 4 squared. I'll tell you, it'll be a fraction. How about I tell you that? It'll be a fraction. This one?
You just divide 48 by 9.
Like this?
And simplify.
Like that? All right, now evaluate that. Is he right? Or is he totally off the wall? Would that be equivalent? Yes, no, or no idea? Where are you at in that, Brandon? Yes, no, or no idea?
I think that's right.
He thinks it's right. Okay. Yeah, I think it's right too. How do we know it's right?
Because you get 12, you divide 48 by 4.
Okay. All right, that's when we look at it. So you took the 48 divided by 4. One thing you can do, and he's right, this is how you would write it. So what's my, that would actually be bigger. So my a squared would be 12, right? My b squared would be 48 over 9. It's not a nice number, but it is what we have to work with. Another way you can think about it, I want to get rid of that 9. I can multiply by 1/9 here, and I can multiply by 1/9 here. As long as I do the same thing on top and bottom, I'm fine. 1/9 times 9 is 1. 1/9 times 48 is 48 over 9. It's just going to be an ugly fraction. We are also saying that 9 over 48 is equivalent to 1 over 48 ninths. If you think about that, 1 divided by 48 ninths is 1 times 9 over 48. That's got to be the same. So if you get stuck in a situation where like these do not divide evenly, you still got to convert it down to here. You just basically take that number and put it on the bottom. Now, I'll be honest with you, typically on a test or quiz, it's going to be made so that it works out nice. If it doesn't work out nice, that's a little red flag. You said, maybe I need to go back and check some things. Okay. But you may have to leave it, just depending if you can't figure it out, you can't figure it out. I just wanted to touch upon those. Doesn't always have to be a perfect square. It can be 12. And this does not always have to divide evenly into that. Okay. For most of our problems, yes, it works out nice. Doesn't have to. Okay. All right, let's go to your notes. Maybe. There we go. All right, I think that. All right, that's the one there. We're on the back, Matthew, on the last one that's on there. And it wants the equation. Find the equation of the ellipse. It has foci 2, -3. 2, 5, major axis test. We're going to give you some different things. You need to be able to put everything together.
Just like a 4 and 9 right now.
Okay. Now, typically, you won't have that graph. I just put it there as a visual if you need it. You know, for me, it helps me. You may be able to think through here and put everything where it's at. What do we need to find, though? I want the equation, final equation. First of all, all right, I'll ask these two things. Can you find the center? And can you tell whether it's horizontal or vertical? How about that? See if you can answer those two questions from the information. Foci 2, -3, 2, 1, 2, 3, and 2, 5, 1, 2. All right, and a major axis of length 10. All right, can we find the center? Aiden, any ideas?
No.
Is that a no or an I don't know?
Probably not. No.
No? All right, not sure. Okay. Kenzie, we find the center. This will be counted as your exam grade right here,
Okay.
which is one question.
I think so because the major axis length is a 2A. So A would be 5.
Okay.
And then from the foci, I don't know. That's all I know.
All right, you give me a lot of information
You
there.
have to count up 5 and down 5.
From where?
That we don't know.
Okay. All right, getting closer. Andrew.
I just met the foci in the middle.
You just what?
Just went to the middle between the foci.
And what'd you get?
2, 1.
All right, that's the center. Your foci have to be equally spaced across the center. So if one's at 2, -3, one's at 2, 5. You just kind of go through there, halfway in between. There's a distance of 8. You got to go 4 units. So what is my center? 2, 1. Is that right? Center. 2, 1. All right, now go back to Mackenzie. She said, major axis is 10. So A will be 5. That gives us the endpoints of the ellipse. Horizontal or vertical? Marissa, horizontal or vertical?
Vertical.
Vertical, because the foci have to lie on the major axis. Okay, they have to lie on the major axis. So the major axis has to be vertical. And what Mackenzie said, I got to go 5 from the center. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, well, what's the equation going to look like, or what do we know at this point? It's a vertical. I'm just going to give you the general form. X minus h squared, and I'll put in the a squared and b squared here in a second, plus y minus k squared equals 1. It's either a squared or b squared. Where's the a squared going to go? What'd you say, Jordan? Under the y, because it's vertical. So that's got to be the bigger one. And then the b squared goes here. Well, Mackenzie, what'd you say we already know? We know a is what?
5.
A is 5 because the major axis is length 10, which is 2a. You cut it in half. A is 5. Do we know what b is? No, but you're gonna have to be able to calculate it. You got enough information to figure it out. How are we gonna figure that out? Andrew?
Use the equation by the C. So if we know C, you just solve for D.
Okay. Yep. What's that equation? Did you say it and I didn't hear you?
C squared equals A squared minus B squared.
Yep. C squared equals A squared minus B squared. Not the Pythagorean theorem, Matthew. C squared equals A squared minus B squared. Okay. All right. We know A is 5. I haven't specifically written down C, but you should be able to tell me what C is. It's going to be the distance from the center to the foci. So C is what? 4. Yes. C is 4. All right. So we got C is 4, A is 5. You plug those in, we can figure out what B is. So 4 squared equals 5 squared minus B squared. Hey, when you're doing your work, if you get negative numbers, that's like a big red flag, like for a final answer. Okay, so like if you subtract, you get like B squared is -9. Probably, either put something in the wrong spot or had something listed incorrectly. So I got 16 equals 25 minus B squared. I do get -9 equals negative B squared, which is just B squared equals 9. I really don't need B because I really only need B squared, but B is 3. Don't forget to write your final answer. X minus, what's my center, 2, 1? We said 2, 1. X minus 2 squared over B squared, which is 9, plus Y minus K squared over A squared, which is 25, equals 1.
Wouldn't it be y minus 1?
Yeah, why did I put K there? Y minus 1. All right. Yep. So I think we're good there. All right, I want to do another one similar to that. If you got room, you can put it on there. If not, go to another sheet. And then we're going to do one out of the book. All right, find the equation of the ellipse that has vertices -1, 4, and 7, 4. All right, take a second, think through that one. Figure out what you can, then we'll go from there. Vertices -1, 4, and 7, 4, minor axis length 2. All right, so let's look at what we got. Vertices -1, 4, and 7, 4. -1, 4, 7, 1, 2, 4. And all right, so you can find the center from here. It's going to be halfway in between. Again, they're 8 units apart, so you're just going to go halfway. It doesn't matter whether they give you the foci or the vertices, halfway in between. So in terms of A, B, and C, right now, what can I figure out? I guess I'm going to word it that way. Hey, any ideas in terms of A, B, and C, what can we figure out?
So you can go like 2 from the center up and down to find the
Minor axis?
Yeah.
Ooh, now be careful. Do we go 2 up, or is the total length 2?
the total length is
So actually go how far up?
1.
1. So we're going to go up 1 and down 1. Now, if you wanted to graph it, that would give us our graph. All right, but how about A, B, and C? Do you know any of those from that information?
So A is 4.
A is 4. Good. That would be the distance from the center to the vertex or vertices.
B
Okay.
is 2.
B is not 2. B is 1. All right, so I got A is 4, B is 1. To get the equation, do I need the C value? No, not technically. I don't need it. So horizontal or vertical? Well, if the major axis is across, it's got to be horizontal, which means it's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. We set our center. Well, you, 3, 4. So x minus 3 quantity squared over 16 plus y minus 4 squared over, what do we get here? 1. 1 squared is 1. Equals 1. Okay, so I get that. More often than not, like ACT test or whatever, if they're listing this as an answer, they're not going to put it over 1. If you do, it's absolutely fine, but it's probably going to be just listed like this. Okay, just listed like that. All right, so you got to be able to take some conditions, figure out A, B, or C, and kind of come up with the equation. Now, ellipses also have some properties that are useful. There's a reflecting property on that number 4. Also, what comes across is the orbits of planets are ellipses. Hopefully, you learned that a little bit in science. The sun is at one focus. Newton, he was a pretty smart guy. Comets move in elliptical orbits around the sun, and we can calculate the distance traveled by a planet in one orbit around the sun. Okay, the reflecting property for an ellipse says that a ray of light originating at one focus will be reflected to the other focus, or any wave will be reflected. Have you ever seen, I don't know if you have, they have an elliptical pool table where if you put the one pool ball here and you hit it, it will always go into the hole on the other side? No? All right, maybe you can make one. So you can do that. So that would be the case. Turn in your books to page 965. We're going to take a look at one there. All right, so if you look at it, they even got the little pool table there for you. But that's 72. All right, something called a whispering gallery. It uses the effect of the reflecting property. So if somebody's standing at one focus and they talk, everything, their voice will be reflected to the other focus. So the person could be 20, 30, 40 feet away. You whisper something, they can hear you like you're sitting next to them. So some rooms are designed in that. And you probably want to know, what are some of the famous whispering galleries? Okay. So since you asked, we'll take a look. See the acoustical properties. So you can figure, you can go here and read and get a little bit of knowledge here. Some examples. The U.S. Capitol building. Did you guys go to the U.S. Washington 7th grade? Okay, yeah, there's a room in there they talked about a lot of times on the tour, where if one person's in one spot, they could hear the person talking in another spot, like way across the room. Did they mention that?
They probably did.
Probably did, but you don't remember. You don't remember? It was a while ago. St. Paul's Cathedral in London is arguably the most famous example. Okay, so if you want to do a little field trip, St. Paul's Cathedral in London, so you can see where this, and Lord Raleigh experimented with sound, so you can recreate his experiment today. So you want to go take a look at St. Paul's. There we go. And I don't know which part of it is, but it's in there somewhere. Maybe under history. Wait, what did it say? For more than 1,400 years. Ooh, that's pretty old for that one. All right, so that's a Whispering Gallery. Now, what Whispering Gallery are we taking a look at? It's where at? In Salt Lake City, Mormon Tabernacle. You don't hear, there used to be a big Mormon Tabernacle choir. They used to be really big. Probably never heard of it. Anybody heard of it? Got their albums? Or wait, their CDs? No. Wait, what do we say now? There you got their music. Anybody? See if they still exist. I think they dropped a new album last week. All right, take a look there. This is kind of the setup. So the vertical cross section of the dome. Okay, so there's your dome. It's not a full ellipse, it's a semi-ellipse. Semi-elliptical in shape. The cross section is 250 feet long with a maximum height of 80 feet. Where should two people stand to maximize the whispering effect? They should stand on the foci. Okay, that's where they should stand. Well, we got to figure out where that is. That's 250. How does the 80 come into play? Make sure you understand it says from the floor to the highest point. So this is 80. I don't need the equation. I just need to find C. C squared equals A squared minus B squared, right? Well, from this information, we have it drawn. What's my A and what's my B and what's my C? Well, I don't know C. What's my A and what's my B? Jordan, what'd you say?
No, never mind.
Cut it in half.
Yeah.
So we're going to cut 250 in half. So A is going to be 125. What's B? Do I need to cut that in half? So B is 80. Bless you. Bless you. A is 125. B is 80. So you just got to watch if they're talking about a full ellipse. This case is a semi-ellipse. And so C squared equals 125 squared minus 80 squared. And that will be some value. 9225. And I want to take the square root of that. And so C is going to equal, is it 96.0? Yep. So 96, since it's 0.0, it's going to make it 96 feet. Where should they stand? They should stand 96 feet from the center. So there you go. All right, I wanted to give you a little bit of time. 10.2 and 10.3 worksheet. 10.2, I want to go back and hit that because sometimes people forget parabolas once we move on. You got to remember this. I will collect this Monday. You got the rest of the period. I am looking for correctness, not completeness. You may work with somebody, somebody's.
Thank you.
I know that I know it.
Okay.
I just felt it.
What?
The version
I'm gonna be
is
honest,
something
I
like
don't
that.
know. I'm put on like, okay, that's fine. Sweats. Okay, thank you. My sweatshirt, and I realized they were exactly the same shape. No way. I got the black. I think I was wearing this exact fit when we already.
Yeah, we did.
It's this is a grouty. It's a grout fit, but it's not as grouty as.
Well, she has the big ones.
I mean, you wear it kind of like yeah, but it's still like.
This is not a dark gray. This is not lighter gray.
It's a darker.
Oh, wait.
See, people.